All right, so we're going to look at the domain and not the range, but the domain of some functions here. So let's see. We have function f, function g, and function h. And the first thing it's saying is find the domain of h of x. Now, all right. So we're focusing only on this one for problem A. So let's write that down. A is, well, h of x is equal to the square root of 2x minus 4. Let's fix that x. And okay, so the domain. The domain is basically all of the x values. So think about if you were to graph something, right? This is your x-axis over here. Where would you not have a value of x? Like sometimes an asymptote, it's sometimes like just a hole in the graph or something like that. So that's what we kind of want to figure out. And if that's not a good explanation, that's fine. I'm going to show you algebraically what that means. So for example, we know that we cannot take the square root of a negative number. Well, okay, I should clarify that. We can't take a square root of a negative number as far as this course goes because we're only dealing with real numbers. All right, so as far as real numbers go, we cannot take the square root of a negative. So I know that this thing underneath the square root cannot be negative. Otherwise, x could be whatever it wants. I could get anything I want underneath here as long as it's not a negative. So what I'm going to do is I'm going to find out what would make 2x minus 4 negative. Or in fact, let me just say that differently. I'm going to find out what would make 2x minus 4 more than or equal to 0. That means that it could be 0 itself because the square root of 0 is 0. Or you could be any number that's positive, as long as I have a positive number there. So add 4 on both sides, and you get 2x is more than or equal to 4. Divide by 2 on both sides, and we get x is more than or equal to 2. Just be careful for like if you're dividing by a negative. If you're dividing or multiplying by a negative, the sign actually flips around. So any number more than or equal to 2 would be part of this function. All right, so x must be more than or equal to 2. I would like to graph this and see, but that's not part of the question, so I'm not really going to go there. If you wanted to write this in interval notation, then it would be all the numbers from, not negative, from positive 2, going all the way to positive infinity and beyond. And if you wanted to write this in set builder notation, then, well, I guess this is just it. X is more than or equal to 2. All right, whatever. Let's do B. So B is find a function and its domain. Okay, so let's focus on finding the function. This just means f of x over g of x. So let's write f of x on top, and you can see f of x is this entire thing here. So I'm going to write it a little bit bigger, well, a little bit with more space there because I want to write a gigantic fraction line. All right, so that's f of x on the top over, because it's f over g. Now we're going to write g. So it says x over 3x minus 4. All right, and they want to know what is the domain of it now. Okay, so I can tell you what's not in the domain. Again, that's how I want to think about this. You want to see what values of x wouldn't work. So something else, you know how you can't take the square root of a negative? Well, you cannot divide by 0. So what number would make this thing here 0? Same thing up here. What would make that thing up here 0? Right? It's the same denominator. So I think we should be okay there. So let's do that. What would make 3x minus 4 0? Right? Because we know it cannot equal 0. So let's just solve it as though it is equal to 0, but keep in mind that we don't want it to be equal to 0. Let's undo that symbol because we want it equaling 0 when we're solving it. Add 4 on both sides, so you get 3x is equal to positive 4. Divide by 3 on both sides, so x is equal to 4 over 3. So if x is 4 over 3, well, then that would make this thing down here 0, which means x divided by 0. That we can't do that. We cannot divide by 0. That'll make it undefined. So this is one thing that x cannot be equal to. All right. Now here's a little algebraic shortcut. If you are dividing by a certain number, then on the top and the bottom, just like how we have a fraction on the top, a fraction on the bottom, you can kind of just eliminate them. I'm not going to get into why that works. It's only a 2-minute explanation, but I'm trying to keep this video a little bit short. So we're just going to rewrite this. And because we had the same denominator for the top and the bottom, we're just going to remove that. Pretend it's not even there. All right, so this is going to be our new function. And right away, I could see x itself cannot equal 0. Otherwise, that would make this whole thing here 0. And that's pretty much it. X could be anything else but these two numbers. Those are the only two things that would give us some type of error if we were to do anything with this. So let's write that in set notation. So 0 comes before 4 over 3 because 4 over 3 is 1 point something. So I'm just going to think about the number line. And x could be any number from negative infinity all the way up to 0, but not including 0, right? That's why we put that parentheses. Union, so you're starting off at 0 again. So all this means is it cannot equal 0. All the way to 4 over 3, right? It cannot equal 4 over 3. And then all the way to positive infinity. All right, so that's how we write that in interval notation.